Imagine scrolling your feed tomorrow morning. You see a hyper-realistic breaking news video of a global leader casually declaring war.
Yeah, and the lip syncing is like flawless. The lighting is exactly right.
Exactly. And how do you prove it's a fake before panic sets in and the stock market crashes? The terrifying truth is that right now, we basically can't do that quickly.
Or reliably, for that matter.
Right. Well, welcome to the Deep Dive. Our mission today is to figure out how you and I are going to navigate a world flooded with AI-generated content.
Without, constantly wondering if our own eyes are lying to us.
We have a really fascinating stack of sources today regarding a technology from Google DeepMind called SynthID.
It is essentially a countermeasure, like a framework designed to tell us what is real and what is AI.
And we are going to unpack exactly how it works. And the best part is you won't even need a PhD in computer science to get it.
Well, the problem of digital provenance, knowing where a file actually came from, has become a total arms race.
Yeah, and the sources position SynthID as a major evolution in that race.
Right. It's a watermarking and detection framework specifically built to make AI output traceable. But they set a critical constraint for themselves.
Which is?
The traceability has to be completely invisible. I mean, it has to happen without visibly or audibly changing how you, the user, experience the content.
Okay, so let's unpack why that invisibility is such a massive leap forward. Because right now, if I want to know if a photo was taken by a real camera or generated by an algorithm, I usually just look at the metadata.
Which we all know is incredibly fragile.
It's like taking a beautifully painted canvas and just, slapping a paper sticky note onto the back of it that says, painted by a computer.
Yeah, and anyone can just reach around the back of the canvas, peel that sticky note off, and throw it in the trash.
Exactly. Like a bad actor trying to pass off a deepfake will just intentionally scrub those EXIF tags or digital signatures in seconds.
But it goes beyond malicious intent. I mean, the infrastructure of the internet itself destroys that sticky note by default.
Right, like when you upload a pristine, metadata-rich photograph to almost any major social media platform.
Exactly. The platform's compression algorithms automatically strip that metadata out just to save server space.
So by the time it reaches your feed, the file is entirely disconnected from its origin. It's just floating out there.
Which brings us to the core philosophy of SynthID. DeepMind realized the sticky note method is, well, it's a dead end.
So instead of attaching a tag to the outside of the file, they are altering the content itself at a microscopic level.
They're weaving the signature directly into the actual threads of the canvas.
Moving from something easily detachable to something intrinsically bound to the media.
Right. And the framework is designed so that the human eye or ear cannot perceive these low-level changes.
But specialized algorithms can effortlessly parse the underlying mathematical patterns.
Exactly.
Manipulating the actual canvas of the digital file makes conceptual sense. But how do you actually alter a digital canvas like a highly detailed image or a complex song without ruining it?
Well, let's look at visual media first. Our sources discuss Google's image generation model, Imagen, and their video model, VO.
So how are they baking a watermark into pixels without me seeing it?
It involves making microscopic adjustments to the color values of specific pixels across the entire image.
So if you look at a high-resolution image of a blue sky, you are looking at millions of pixels.
All registering as slightly varying shades of blue. SynthID mathematically adjusts the color values of specific pixels.
Or the shifts are minute.
Oh, very minute. Perhaps changing a blue value by a fraction of a percent. It falls far below the threshold of human perception.
You just see a normal blue sky.
Exactly. But a detector model doesn't look at the sky, it reads the data.
And in that data, those specific microscopic color shifts form a highly consistent pattern.
That's the watermark.
Okay, I had to push back on this, though. Because people do terrible things to images on the internet.
Oh, absolutely.
A pixel-level tweak sounds incredibly fragile. What if someone takes that AI-generated image of the blue sky and crops half of it out?
Or resizes it.
Right. Or slaps a high-contrast deep-fried filter over it. Or, the most common scenario, what if I just take a screenshot of the image on my phone instead of saving the original file?
Doesn't all that noise completely destroy a microscopic pixel pattern?
That's exactly my question.
Well, you've identified the exact vulnerability of traditional spatial watermarks. The ones that act like a translucent logo hidden in the corner of a photo?
Right. If you crop the corner, the watermark is just gone.
SynthID circumvents this by operating in the frequency domain of the image. The pattern isn't a single localized stamp.
Meaning what, exactly?
It is a distributed mathematical formula encoded throughout the low-level frequencies of the visual data.
So the math is baked into the relationships between the pixels, not just the individual pixels themselves.
Exactly. Because it is distributed globally across the image's frequency domain, every single crop, every fragment of that image contains a localized version of the mathematical formula.
Oh, wow. So the detector isn't looking for a perfect, pristine match.
Right. It is trained to recognize the statistical likelihood of that specific mathematical footprint existing amidst the noise.
So if you apply a high contrast filter, or compress it, or take a screenshot, you are adding noise.
But the underlying statistical footprint of the SynthID algorithm survives that noise.
The footprint survives the filter. That is wild. Okay, so that's visual data. But what about audio?
Right. The sources detail Google's audio generation model, Lyria.
Pixels are one thing. I mean, you can hide math in a color gradient. But if you are listening to this deep dive right now on Spotify or Apple, your phone is aggressively compressing the audio.
Right.
How do you watermark a sound wave without making it sound distorted or, introducing a weird hum that ruins the song?
Audio presents a unique obstacle because raw audio waveforms are incredibly volatile. If you try to hide a pattern directly in the waveform...
The second you apply standard MP3 compression, the pattern is obliterated.
Exactly. So SynthID takes a fascinating detour. Before the audio is finalized, it is converted into a spectrogram.
Okay, for the listener who hasn't spent time in audio editing suites, a spectrogram is essentially a visual representation of sound.
Like a heat map of frequencies over time.
Right. The higher the pitch, the higher on the graph. And the louder the sound, the brighter the color on the heat map.
It translates acoustic energy into a visual matrix. And once the audio is in that visual spectrogram format, the SynthID framework can treat it almost like an image.
It embeds the watermark pattern into the visual heat map.
But it does this selectively. It targets specific frequencies that the human auditory system naturally masks or filters out anyway.
So it might slightly shift the visual volume of a high-end frequency.
Because your brain is already ignoring it due to a louder sound happening at the exact same time.
Wait, so we are turning sound into a picture, watermarking the picture in a way our ears won't notice, and then turning it back into a sound wave.
Yes, exactly. The altered spectrogram is converted back into the final audio file.
And because the watermark was embedded in the frequency relationships on that heat map, it becomes incredibly robust against acoustic manipulation.
Because if a DJ takes an AI-generated track from Lyria and decides to slow down the tempo or time stretch it...
The watermark stretches with it.
Right. The relative distance between the embedded frequencies remains statistically significant to the detector.
So even if you add background noise or compress the audio heavily for streaming, the detector isolates the spectrogram data and finds the embedded pattern.
It's remarkably resilient.
Okay, hiding math in millions of pixels or a massive spectrum of sound frequencies makes sense. You have a massive continuous canvas to hide things in.
Right, plenty of room to operate.
But here's where it gets really interesting. What happens when you strip all that continuous data away? What happens when you just have rigid black and white text?
Text requires a completely different architectural approach. I mean, you cannot hide data in the color of a word.
Or the frequency of a letter. A word is either there or it isn't. You can't make the word the 2% darker without the reader noticing. So how on earth does SynthID hide a watermark in a sequence of words?
To understand the text application, specifically how it works within Google's Gemini models, we have to look at the mechanics of how large language models actually write.
Right.
They don't think in full sentences or paragraphs. They process language in tokens, which are essentially words or fragments of words.
Right.
When an LLM is generating an answer for you, it is rapidly calculating token probability scores for what should come next.
So it looks at the sentence so far, runs the math, and creates a rank list of the most likely words to follow.
Exactly. If the sentence is, the cat sat on the...
The model calculates that Matt has a 90% probability, couch has a 5% probability, and refrigerator has a 0.01% probability.
And through a process called top case sampling, the model normally selects a word from the highest probability tier to construct a natural-sounding sentence.
Okay, I'm following.
This is where SynthID intervenes. During the generation process itself, SynthID introduces a dynamic algorithmic bias into those token probability scores.
It slightly tweaks the choices the model makes, shifting the probability distribution.
Yes.
Wait, I think I have an analogy for this. It's like playing a board game with weighted dice.
Oh, I like that.
But it's not just that the dice are constantly weighted to roll high numbers.
Yeah.
That would ruin the game, or in the case of the AI, It would result in terrible grammatically incorrect writing.
Precisely. If you force the model to pick low-probability words just to form a pattern, the AI starts hallucinating or sounding robotic.
So the dice are dynamically weighted.
Yeah.
Let's say the AI is playing the board game, and the underlying algorithm ensures that every fifth roll is guaranteed to be an even number, regardless of what the game board looks like.
Right.
To the human players sitting around the table, a sequence of rolls like 4, 6, 2, 8, spread out over an hour of gameplay, looks like completely random luck.
The story of the game makes total sense. Nobody suspects a thing.
But a computer watching the game from above, tracking every single roll over time.
Sees the undeniable mathematical signature.
Wow.
The detector doesn't look at the meaning of the words, it looks at the statistical distribution of the choices across the entire paragraph.
The insight here is that an AI doesn't write words, it writes math.
And SynthID systematically adjusts the math behind the text so that the final sequence of words encodes a hidden statistical pattern.
If the detector scans an essay and finds that specific, highly improbable sequence of token choices, it can confidently confirm the text was generated by that specific AI model.
You are hiding the fingerprint in the AI's decision-making process itself.
That is incredibly clever. So what does this all mean for the real world? We understand the mechanics now, frequency domains for visuals, spectrogram heat maps for audio, and dynamic probability weighting for text.
Right.
How is this actually deployed in the wild?
Well, if we connect this to the bigger picture, the sources emphasize that this has moved far beyond theoretical research.
Oh, really?
Yeah, SynthID is actively deployed and integrated across a broad ecosystem of Google's generative products. It is operating inside Gemini for text, Imagen for images, Lyria for audio, and Veo for video.
They are constructing a multimodal web of provenance.
And to actually find these watermarks, they operate a detector service.
Like a separate portal where this media can be scanned.
That's right. The detector service can scan a piece of content, parse the mathematical noise, and return a verdict on whether the content contains the SynthID watermark.
And the stakes here are massive, going right back to our scenario at the beginning. The sources explicitly outline how this tool helps platforms, creators, and regulators distinguish AI-edited media from human-created media.
Which is critical for fighting deepfakes and fake news.
If a hyper-realistic video of a global leader goes viral, a social media platform could theoretically run it through this detector service behind the scenes.
If the math lights up, they can instantly flag it as an AI generation before it crashes a market or swings an election.
It provides a mechanism for establishing trust at the infrastructural level, rather than relying on the end user to manually scrutinize every shadow or audio glitch in a video.
Absolutely.
But let me play devil's advocate for a second here. Does this actually solve the deepfake problem?
Not entirely, no.
If I am scrolling online next year, can I completely trust that if a video doesn't have an AI watermark, it must be completely real? Like, have we secured the internet?
No. And the sources are very careful to temper expectations on this exact point. SynthID is not a silver bullet, and it does not solve misinformation entirely.
Why not? I mean, if the watermark survives cropping, screenshots, and heavy audio compression, what is the loophole?
The limitation isn't the technical robustness of the watermark. The limitation is the scope of adoption. SynthID is a framework developed by Google DeepMind. It currently marks content generated by their specific systems. But a watermark cannot magically apply itself to all AI models in the world.
Right. There are open source models anyone can download, models built by other tech conglomerates, and proprietary models built specifically by malicious actors to generate untraceable deepfakes.
If a bad actor generates a fake audio clip using an entirely different, non-watermarked rogue AI system, SynthID's detector isn't going to find anything.
Because the mathematical signature was never embedded in the first place.
Exactly.
It's like having a highly advanced detector that only flags counterfeit $100 bills if the counterfeiter was polite enough to use the government's official counterfeiting.
That captures the limitation perfectly.
If they just use different ink, the machine stays silent.
Furthermore, the sources note that different modalities have varying degrees of robustness. Text, for example, is inherently shorter than a massive video file.
Meaning there's less data to hide the statistical pattern in.
Right. If you only generate a 3-word sentence, there isn't enough statistical distribution for the detector to confidently identify the watermark.
So it's not a foolproof shield. But the sources also argue that despite these limitations, this kind of technology is absolutely critical.
Because it establishes a foundational building block for a responsible AI ecosystem.
Right.
If The major, easily accessible, high-quality generative models, the ones used by the vast majority of the public, adopt invisible, robust watermarking natively. It dramatically shrinks the dark forest where malicious, untraceable AI content can operate freely.
It sets a technical standard for provenance.
Exactly.
It proves that we do not have to rely on the fragile sticky notes of metadata anymore. The technology exists to track origin at the pixel, audio, and token level.
Which is a huge step.
Which means the next hurdle isn't really technical, it's societal. How do platforms choose to integrate these detector services? And more importantly, how is that information presented to you, the user, when you are scrolling on your phone?
Right, because knowing a file is AI generated in a server room is only half the battle.
You actually seeing a clear, undeniable flag on that video before you hit share is the other half. Well, to summarize our deep dive today for everyone listening, we are officially moving past the era of fragile metadata tags.
Finally.
Frameworks like DeepMind's SynthID are giving us a way to weave invisible, highly resilient mathematical patterns directly into the DNA of our media.
Whether it's encoding formulas into the frequency domain of an image or hiding patterns inside the frequencies of an audio spectrogram that our ears naturally ignore.
Or dynamically weighting the token probabilities of AI text generation. This technology is allowing us to verify digital provenance even when files are compressed, time-stretched, or screenshot.
It is a massive technical step forward for establishing trust online, even if it cannot unilaterally catch every rogue AI model in existence.
It leaves me with one final lingering thought for you to ponder as we wrap up.
Oh, let's hear it.
We've spent this entire time exploring how AI is becoming incredibly adept at perfectly embedding these invisible, complex mathematical signatures into everything it produces, just to prove its identity. But if AI becomes mathematically perfect at leaving a flawless, distributed signature in its art, its music, and its writing,
Yeah.
will there eventually come a day when the only way to prove a piece of media was created by a human is if it lacks that mathematical perfection?
That is a fascinating thought.
Thanks for joining us on this deep dive. See you next time.